All right, ladies and gentlemen, nothing but a little update, just to show you how it was going and what it looked like while it was getting there. Got the controller in the front. The bottom bracket is up on top. I can't get to these bottom bolts the way it is. If I had it on its side or something, maybe. But what I'm going to do is take it off because it's good now. And take it off and get the bottom bracket on. It just, it's a little bit off centered because of the thermocoupler. That made the difference because I had to drill a hole all the way through the box, and so it had to align. And so I didn't have it perfect when I was guessing, and when the rubber hit the road, it wasn't exactly the same, is what I'm saying. Probably take this apart and either bend the steel a little bit so it re-aims, or I'll take a little bit of the kale wool. That's that stuff right there, y'all. Got it down for the back of the box. The piece on top is going to fit behind the box here. These little strips will help. The brackets will pinch it on the top and bottom. This will get cut, stacked together, and then cleaned all up so they match, and then drill the holes so they match. Whenever you're building anything, just word to the wise, don't make it so every piece only fits in one spot in one direction, in the proper orientation. Don't do that. Make it as universal as you can. You'll thank me later for that one if you didn't realize that already. And I think if you're over 10, you probably realize that one. But it makes it really hard when you're trying to build stuff. So it was a little bit off on the centering, but at least they match top and bottom. That's all that makes any difference. And they're the same. And I didn't have a brake that big, the stainless steel, 1/8" stainless steel. So I had to use the bed rail on my ton truck, bend it over, and use a sledgehammer to beat it over. And that was the best I could get for a sharp corner. That was it. But it'll be fine, and it'll be, like forever and ever, amen. And it's the least conductive on heat. And then when the kale rolls on the back, that'll stop everything. That's quite a thickness of kale roll there. Like I said, just a little wrap around, as I'm filling it with sand, is stop and just wrap that one section of pipe, with a thin little piece. That's all it would take, and then just keep filling it up with sand. Just so the thermocoupler is not getting a false read, is what it is. I got everything marked for tomorrow or the next day. I don't want to do it. I don't want to race. I want the concrete the cement to get much harder if I can, and then I'll tap these off, cut it proud of a line, and then sand it down to the line, and then reassemble everything. I'll probably clean everything up like extra better, sand everything better is what I'm saying, so everything fits a little bit looser, and then it should drop back together with no problem. That's what I was going to show you. Where all that mess of cable is right there. That's where the thermocoupler comes through the back. I ended up just making these brackets here that hold I can't even point to it. Is that I hold to the back of the DID rail for the I can't turn that. Wow, that's really heavy, and I can't imagine what that's going to be like with the sand in there too. That little dude ain't going nowhere. But we got the breaker in the bottom that'll turn off the element. The fans will be, if the plug is plugged in, the fans will be on. That's just it. I may put a interrupt on 2 of them, or with use one of my older PIDs, just for thermal, for the thermal. I don't know, but otherwise, they don't use that much electricity, and I don't want this thing running without the fans. I'd rather the fan, if it's plugged in, it's not that big of an electric issue. for the power is what I'm trying to get at. Got the solid state relay mounted and all that. Everything will have to come out to get the bottom and the sides done. That's why these holes, if you look on the side of the board over there, there's only about 3/4 of an inch, half-inch room to maneuver in there, and I can't hit nothing. You know, I mean, that would be bad. So with the screw is what I'm trying to say, is in the back side of that as well. But there's nothing over there is what I'm trying to get at. And yeah, I probably could have used just one of the DIN rails and stacked them side by side. I don't know. I always thought if it was bigger, I would have bigger fans or more of them, and they would have another breaker along with these other breakers in the front. But there's always room for improvement. You know, you don't hardly ever get it perfect the first go around. That's why it's called 3E for the third rendition. But I think that's going to stick, that 3E thing. I like it. Like it enough is what I'm trying to get at. Nothing else really to show you or nothing like that. It all went together well, just kind of how I described it. We'll tap these apart, cut them, sand them, put them back together, and it should be fine, and then we can get the lid on, and that'll allow me to roll it over on its top. Because like right now, these little exhaust tubes, they stand proud by about a half an inch, and I can't really lay it on its side. Well, off kilter I could, but I can't lay it on its top because these are proud of the top of the deal. Just screwed up there. I should have marked them at the top of the tank, but I laid a pipe across and I marked it at the top of the pipe. And that was my mistake. But it's all good. They're done and we'll get it fixed. Just getting it done, that was like bagging cats. Wow, that was something else. Because it was all loose before the cement hardened. So, but that jazz is better now that it's solid up. Don't got nothing other than that. That was my only update, y'all. And I just didn't want to get too far along with this without like showing you the progress, especially when it came to that. The brain has its box, so we're good there, and we'll get it all. This one goes on the bottom down there, but like I said, I just can't get my big hands in there to do it. Other than that, that's it, y'all. Y'all have a big day. I hope it's in the middle of the afternoon or getting close to the afternoon. We are at 29.1 on the. What is it? No, it's all over the board. Oh, it must be clouds passing over. Yeah, we're like at 39 volts, real close to 39 volts. The floor is, I don't think you can see that. Now they're going to act all goofy. The floor is at 106, 107. The saturation temperature is probably in the 90s. I'll shut this down here in a little bit. It had a pretty good day heating it up. We're going to get some pretty cool days, like in the low 20s with clouds. So we won't have the radiant energy from the sun, and we won't have the solar to heat it up. So try to take advantage of it while I can. And that's henceforth where this little dude comes in, because its bigger grown-up version brother will be in a full-size aluminum tank with a pontoon tube over the top of it, sleeving it with copper on the outside, and then like this PID controller, it'll probably have the PLC, the programmable logic controller, so it can do a bunch of stuff like measure the air temperature, measure the flue temperatures, measure the water temperature all at once, measure whether the fans are running, adjust the fans. That other controller can do. This can do some impressive stuff, dude. This is. I couldn't even imagine trying to keep up with what this is going to keep up with when it's programmed right. And it would keep it from self-destructing at 220, It'll keep it just at the non-self-destructive temperatures that it needs to be, so it's not self-destructive. It's not a good device if it can't perform and it keeps costing you money. You got to get over that part. And that's a lot of these videos that I see. What's wrong with them is they either overheat them, they die, or they have no way to change out the element later. There's always a weakness, is what I'm trying to get at. This third rendition, the first two were kind of weak too. I can't say they weren't, but it was full throttle at 1,000 watts, and that's too much. That could melt brass. I got a video proving that, is what I'm trying to get at. That's too much. This is 335 watts, making about 600 degrees, and that should be in the sweet spot, is what I'm trying to get at. Not probably as for a thermal store for to do hot water, but for just air-to-air exchange, this should be fine, and it shouldn't burn you at 600 degrees. If it does, we'll back it down. That's all, hence for what that's for. That actually, all this is to force air through the tubes, but what it's really for is for the 220 when I get that far. 220 single phase, because I'll be able to adjust it on voltage, and that'll make all this stuff work really well. I'll be able to throttle this, when this is a bigger tank with two elements, I'll be able to throttle it, the second element, like a variable resistor, is what I'm trying to get at. But very good is what I'm trying to, 240 split phase has its purpose to weld air compressors, industrial stuff like that. 220 single phase has its purpose too, for doing tricks like that, is what I'm trying to get at. Okay, guys, that's all. I already ate dinner. It's in the afternoon. We're got this one shut down for the moment. Probably have to turn it on here directly. I'll go out and check the clouds before I do, so it don't go over voltage, is what I'm saying. But it'll carry me another hour and a half into the evening if I turn on the front array. Or I can just shut off the floor. 107 degrees, that's pretty warm. I don't need it much warmer than that. That's why I wish I had a much bigger sand battery built, is what I'm saying. I would love to find like one of those industrial size scale containers, and then design something to fit it. You know what I mean? Like a sugar vat. I can think of a few things back in Arkansas where they store the sugar and it has the mixer in it. Stainless steel, but they're like 1,000 gallons, is what I'm trying to get at. With that, you would have enough stored mass to keep the hot water rolling for days. It would be the way to do it, is what I'm trying to get at. Same design. You go up with the flue pipes down, exit at the bottom, put your another cap over the top of this. The same fan setup. When you need more hot water, the fans would kick in, blowing hot air, but you would let it be full tilt at the 220, so it's in the 1,000 degree range, 1,200 degree range in the inside. But you only extract the heat by the forced air blowing it underneath the skirt of the other drum. And then you'd have vent at the top versus the bottom on the second skin, is what I'm trying to get at. But aluminum, it has thermal conductivity in the 200s. So it would actually disperse the heat, is what I'm trying to say. And you're only trying to get it hot enough to get like 200 degree water-ish, not even. Like 107 is more than enough, is what I'm trying to get at. 200 would be ridiculous, but it would take you through the cold. I'm actually thinking about this for like Alaska, in different places. I got friends up there that I'd love to see them do something just like this, is what I'm saying. Could they do it all summer or winter long? No, not really. Only because of the because of the tilt where it goes black, for 3 months. But for the rest of the year, it'd be a pretty sound way. And if you got to run a generator, that's a perfect way to store the extra energy, or to convert it into heat, is what I'm trying to get at. For the generator, it's a sound way, is what I'm saying, efficient. So, all right, y'all, I'm going to cut it off and leave it here. Talk to you then. Hope you have a big day, better tomorrow. Happy trails, toodaloo, and all of that. All right, bye.